Right, we are back. This is Techmath 1. We're looking at 9.6 in the blue book. Chapter 9. So 9.6, additive, inverses, and addition, subtraction, conversions. So yeah, only one problem off in 9.6 here. 48 on page 388. All right. So we're looking at, they have problems that they would like us to convert to subtraction problems, which are pretty easy actually, right? So we've got okay. So here we are. This is just v minus t. That's it. Plus a negative is a synonym for minus sign. After you learn about integers, minus signs don't mean the same thing that they used to when you were just in the whole number system. When you're in the whole number system, you couldn't take away more than you had because the lowest number in the whole number system, the lowest element, is 0. And so you can't go less than that. After you learn about integers, positive and negative numbers, well then the minus sign takes on a different idea. So it's already in kind of integer form, plus and negative. And now we're just converting it to minus because it's just easier. It's easier shorthand is all. So you're just aware now that after you've learned about integers like that 7 minus 12 is negative 5. That's the same as 7 plus negative 12 is negative 5. Either way, it's negative 5. It's just this takes on kind of a different meaning than it did when it was in the whole number system. In the whole number system, you would have said you can't do that. If I have 7 markers on the table, I can't tell you to take 12. That's restricted by the whole number system where after 0, there aren't any markers. Where here is more abstract with negative numbers. So plus and negative and minus are basically interchangeable. And so because they're interchangeable and we're lazy in math, less symbols is better. So we don't do minus. We don't do plus negative, we do minus because it's just less stuff to write. So f1 r sub 1 minus f sub 2 r sub 2 c squared minus a squared. All right. And so there we are. Let's take a look at 9.7, the addition axiom. We'll look at 53. So number 53 is solve for the indicated variable. So they're telling us to solve for e. And they have h is equal to e plus pv. So what we're going to do to solve would be subtract pv from both sides. And so even though we can't actually subtract it, what we're doing is we're manipulating the formula or the equation. So E is equal to H minus PV. So it depends on what's given. If they give you E and P and V in a problem, you'd want it solved out for H. So all you'd have to do is sub it in and it would be an easy substitution. If instead they were always giving you PV and H, well then you might want to solve it for E once and then just sub them in to this formula, this version of the same formula. So instead, of going back to your sweet algebra skills, which would be, let's say they gave me H and PV and I put it in here, and then I'd have to solve. If it's already solved out, you can just use this formula every time. All right. Oh, there's a second one. So here, for R in the following formula or equation. So if they want me to solve for R here, we would just subtract S and subtract T. Subtract S, subtract T from both sides. They're unlike terms, so we can't really do anything. So it ends up D minus S minus T is equal to R. And there we are. Computer programmers do this all the time because usually if they're writing a program, they'll write different versions of the same formula with however many variables there are. So that you can say, you know, give me this, give me this, give me this, and then the program will just do it for you. So you see this a lot in computer programming. 57, c squared equals a squared plus b squared. And they want me to solve for b. So this is going to add a wrinkle to it. Oops, wait, there's got to be equals in there. All right, so we subtract a squared from both sides. So you got c squared minus a squared is equal to b squared. And then we take the square root of both sides. But again, that would be, because it's a second degree equation, we would have a plus or minus in front of that. And now here's the other thing that's very, very, very important that you understand. So because it's likely talking about a distance, we'll get rid of the negative. So this is our answer. B is equal to the square root of c squared minus a squared. That is it. Do not ever, ever in mathematics take this square root and apply it to the number being subtracted from the other number. I had a bunch of students do this in the past in this course where they messed it up. You can't distribute a square root over a plus or a minus. It's not allowed. You can distribute it over a multiplication sign, but not over a plus or a minus. So what does that mean? That means if it were this, r is equal to the square root of s squared t squared, you could take the square root of s and the square root of t and just call it st. And that would be fine. That's being multiplied. If it's being added or subtracted, you cannot take the square root of just parts of a binomial or a trinomial or any monomial. Or monomial is okay. Sorry. Binomial, trinomial, or polynomials 4, 5, 6, 7. All right? You can't take the square root and apply it over a plus and a minus sign. It's not allowed. All right? It's the same rationale behind this. If you had x to the third, y to the fourth, quantity to the fifth, you could do that. You could say, oh, that's x to the 15th and y to the 20th. That would be fine. But if you had this, x to the third plus y to the fourth raised to the fifth power, that would be a very different problem because you can't distribute a power over a plus or a minus sign. So you'd have to write that out 5 times and then do FOIL and then do FOIL again and then again and again and again. It would be a really big, long, involved answer. So these are very different problems. In the same way, this is like to the 1/2 power, essentially. And you can't distribute a power over a plus or a minus ever. Okay? So that is your answer. Let's look at 9-8. We'll jump to number 65. So 65 is on page 393 of the blue books. And what are we doing here? V naught squared is equal to v sub f squared minus 2gs. And they want me to solve for s. Okay, so they just upped the game a little bit, no big. So first, isolate the variable. Let's go back to an easier problem. All right, here, I'll just write it on that edge here. Look, if I had 2s plus 7, negative 2s plus 7 was equal to 17. What you would do to solve that equation, that would only have a single variable in it. I just made that up. I just made up that problem. We would subtract 7. That would give me negative 2s is equal to 10. And then we would divide by negative 2. And that would give me s is equal to negative 5. All right, nice concrete problem. This is very abstract, but it's really about the same problem. I could rewrite it so it looks the same. In fact, I'm gonna. Let's go negative g at s, negative 2gs plus v sub f squared equals v naught squared. What did I do first? I isolated the s, so I subtracted 7 from both sides. What am I going to do first? This is the one that I'm after. All the rest of these I'm treating like those numbers. So I'd subtract v sub f squared from both sides. What did that do for me? Well, it's isolated the s. I've got negative 2gs all by itself now on the left side of the equation. On the right side of the equation, I got that. Then what did I do over here? So I got rid of the 7, that isolated it, and then I divided out the negative 2 on both sides to get 1s. I'm going to divide out the negative 2g on both sides. That's all the way, big long divide by sign. Or you could do two individual ones. You could go divided by negative 2g divided by negative 2g. All right. And that is s. Let's see. They didn't. They just left it like this. So this is fine. If you worked ahead, if when I said that number, you just jumped on it and did it, and you wrote it out, this is fine. This is great. What they did, if you look carefully, they switched up. They divided the negative throughout. And so this, I want to stress, this is fine. On a test for me, this is fine. It's the same thing. What the book did was they went like this. They put the negative on, they multiplied the top by -1 and the bottom by -1. And so the top divided by -1, that becomes a negative, that becomes a positive. And then on the bottom, they just left it 2g. And then they rearranged it. So if you notice that they have them rearranged, there wasn't a mistake anywhere. They just multiplied through the negative, which is fine. If you want to do it that way, you can do it that way. Another way to look at it would have been like this. If you worked ahead and you like that, like divided each individual term by -2g, then we should really simplify it. So this would be negative v naught squared over 2g, and this would be positive, because a negative divided by negative is a positive. That would also be fine. So this is fine, this is fine, this is fine. Any of those three. I do not really care if you leave the negative there. This book always distributes the negative through, so you'll never have a negative in the bottom. But there's not a mathematical rule about that. That's just what the preference of the authors of this book. All right, so let's take a look at 9.9. Oh, if you're in German, that's no. 9. So 9.9, let's look at 67. That is m is equal to b times d plus t. And they want us, what do they want us to do here? Solve for t. Okay. All right, so there's two ways to attack this problem. I'll show you the first way. Distribute the b. So you got m is equal to bd plus bt. Then isolate the t, so subtract bd from both sides. M minus bd is equal to bt. And then divide everything by b. And there we are. T is equal to m minus bd over b. And that's fine. You can leave it like that. If you wanted to, you could also divide it individually. M over b minus bd over b, in which case the b's would cancel on that term, and you'd have m over b minus d. This would also be fine. You don't have to do it. You can do it like that. You can do it like this. Either way, there is a third way to do it. And when you do it this way, your answer is going to come out looking more like this one instead of this one. I still think this is the easiest way, even though you did the distributive property and then had to, subtract and divide. There's a third way. That is, you do not, since this is the one that we're after, instead of complicating it by distributing, you could divide both sides by b off the bat. That gets rid of that. And then just subtract d from both sides. And we're right back to this answer. So any of these methods are fine. Like I said, I think this is the absolute easiest way to understand it. We're all very used to doing the distributive property, isolating and dividing. You want to do it individually, that's fine. In algebra, we do it this way a lot because you're usually working with linear equations. You're trying to find the slope and the intercept of the line. But either way is fine. Whichever way makes more sense to you, do it that way. All right, and then let's go to 9-10. And number 75. And that is on page 398 in the blue book. Okay. All right, so let's see. Show that the right solution is equivalent to the left solution. You can add the fractions and the non-fractions. Okay, so let's see what they got here. They say L is equal to M over P plus X is equal to M over P plus P X over P. Okay. So we're supposed to show that that's equal to M plus PX over P. Sure. Right? Because you have a common denominator. So what they did there by showing, I think maybe they wanted us to explain how did you get from here to here? We had a P on the bottom, and so that's like over 1. And so you say, oh, common denominator is P. So I multiply top and bottom by P, and that gives me PX over P. And now I have that common denominator. So I can write that as one single thing, and then that plus that on the top. So I think that's what they wanted me to explain. All right, so then let's do another one, number 80, where they want me to solve for m when I have b is equal to c times d squared minus m squared. All right, so this is really just the same as what we did before. It's just a little more, you know, they've got a negative in there and a squared in there. So we'll go like this. All right. And then we'll subtract CD squared from both sides, CD squared from both sides. So B minus CD squared is equal to negative CM squared. So they're going to have us divide everything by negative C. I think it might be easier. I don't know which way is easier here. Negative C. Like that. They're definitely going to do this trick where they multiply top and bottom by -1. So they're going to have this negative B plus CD squared all over C. All you did was you multiplied the bottom by -1, that got +1, and the top by -1, that became a negative, that became a positive. And so you distribute the negative throughout, basically. Squared, and then their last step, like I said, algebraically, we would say plus or minus the square root. They would definitely write that first and that second, just to be a little lazy. Over C. And then likely they ditched the negative. So algebraically, there are two solutions to this equation, but in reality, it's likely restricted to just the positive, and so that's likely what they put down as their answer. Let's see. Yeah, either one. They have that, or they had it like individually, where you divided negative C into that, negative C into that. Again, we can't do anything about this d squared because it's being added or subtracted to this b. So we can't play with the square root and the square. You can only do that if it's a monomial, if it's all one term all being multiplied. Then you can play around with, you know, getting things out from underneath the square root sign. Oh, also make sure your square root sign was better than mine, where it's clear that the C is captured under the square root. Don't give me any like where it's close call, where I'm not sure if it's on the top or the bottom. All right. And then let's forget there's a second one on there. And that'll be the last one we do on this video. So the second one is for G. This is still number 80. It's part B is equal to VRG squared minus H squared over 100. Okay. So let's cross multiply and solve. So we got this. We got R times G squared minus H squared equals 100 times V. All right, now we want to solve for G, so we'll do the distributive property and get R G squared minus R H squared is equal to 100 V. Then we want to isolate the G, so that means this has to go away. Well, it's a minus RH squared, so we add RH squared. That'll zap that from this side, but we got to do the same thing to both sides of the equation. So I add RH squared to a minus RH squared. Those are gone. I add it to that. I really can't because those are unlike terms, so it just stays. G squared equals 100V plus RH squared. All right. Now, since the last one I just did a big long line and left it underneath like that, this one I'll do it the other way, so you can pick which way you like to do it better. I'll divide each thing by R. How about that? So now we got g squared is equal to 100v over r plus, those r's would cancel, h squared. And now we do the square root of both sides. I'll sneak in my little plus or minus, but I'm going to cross it off just as quickly because they're only talking about the positives. So g is equal to the square root of 100v over r plus h squared. Okay? Again, even though 100 is a perfect square, even though h squared is a perfect square, because of this addition sign, you cannot do anything. You can't simplify the square root over a plus or a minus sign, ever. All right? So that is number 80. All right. Next set of videos will be 9/11.